Alright, welcome to the August 23 developer update. Let's go straight to the TLDR. As of Blender 4.0, the legacy Python PLY API will be deprecated and probably not shipped with Blender anymore. Which is okay because we now have new C++ modules, which were great when they work. Unfortunately, there are some minor bugs that we're working with. However, this has caused the situation to get a bit more confused. We'll cover that more in a moment. New life for the Python API. There I thought it was obsolete because it was deprecated, but no. A researcher by name of Katie Jarvis sent me a most awesome email from the University of Rochester. The Triforce Institute is doing nuclear simulations with their badass super huge laser and using Blender in the process, which in turn caused her to add some stuff to import PLY as verts. And so that's really good news. She made some kick-ass edits to it. Stuff that I hopefully would have thought of at some point, but did not. So we're going to merge her branch into the main. And lastly, we have a new website in support of all this PLY stuff. It's called the plyguy.xyz. XYZ, not y.com or .org. Well, those were also very expensive domains. But, you know, I'm not a company, does .com, nor an organization, .org. But XYZ, that's 3D coordinates. Yeah, okay, we got plenty of them. Cool. So there's not much on the website yet, but stay tuned. It's more kind of the support stuff for everything that's not quite technical enough to put on the GitHub repository. It turns out that the new C++ modules are about an order of magnitude more difficult to try to edit and or debug because you have to set up the entire Blender source code environment, and I haven't actually done this yet, but I think you have to go through the process of actually compiling Blender from source once, all of it, and then you can just isolate the module that you want. And again, you know, I've been doing C++ for 30 some odd years to one extent of success or another, but that is way, way harder than just loading up a Python file into Notepad++ or your editor of choice, making some changes, saving it, rerunning Blender, and you have immediate results. And so as a result, I think the Python branch, even though the Blender Foundation has given up on it, it's going to have a good second life because a lot of these science and data types don't necessarily have time or ambition or need to learn something like C++ to the extent that you would need to say your simulation requires you want a couple more attributes to be stored inside your PLY file like Ms. Jarvis did. Saddle up, especially if you don't know any C++, because to get something like that working reliably inside of a larger ecosystem of Blender, well, yeah, that gets complicated. And so what language do most science folks use? Well, it's Python, of course. It's really good for that. And what better place to have an open source repository of this big PLY thing that we're making than import PLY as verts? And so, yes, we're going to be adding in a lot of Katie's changes because she made some really good stuff. Consulting my notes here, forgive the lack of eye contact. In addition, we're going to finally make the thing a proper add-on, since we no longer really have to base this upon the Python legacy code that's been in Blender since, I think, 2015? Possibly earlier. I have to fact check myself on that. There'll probably be a quote right here, but alright, so I'm going to read the email from Ms. Jarvis because it is very exciting. She says, "Hi, my name is Katie. I'm a current college student who has been using your import PLY as verts add-on for the past year or so as part of the research that I do with a physics team I'm working on that focuses on particle simulation. I saw that Blender incorporated a lot of your changes into the most recent 4.0 update, which is super cool, but I noticed they still don't have an option for custom attributes that aren't just location and color." Very true. Very true. I interrupt her email just for a brief moment. Even my old go-to work by, especially for stubborn models or guys like working with Cloud Compare, we're working on it, guys, hang on there. would be just to run it through MeshLab. You know, import your stubborn model and then re-export it as a ply, and it comes into Blender usually intact. Well, I'd never noticed getting under the hood that it actually does strip out almost everything beyond, well, like she says, location and color. And well, that's okay for like standard models, but when has this project ever been about standard models? I got into this in 2017 because I was an edge case. Damn it. Anyway, I digress. That's my strong point. But yes, MeshLab is not the Swiss Army knife that I thought it was, especially for additional attributes. And really, I apologize because I forgot that there are, you know, this is kind of what Ply was invented for, was point clouds and cool physics stuff like this. I hadn't considered, say, a simulation workflow in which there might be hundreds, thousands, maybe more, of additional variables that you need to track over time, and Blender / MeshLab / import Ply as verts, everything other than what Ms. Jarvis has made, will not load. So, we're going to address this. Back to the email. This summer and some of last summer, I made some personal edits to your Python code that allowed for reading of the Ply header in order to create custom named attributes. Most surely, the heart and soul of open source. Take my hack, add your hack, and we make a really good hack. That's a bit hacky. I will admit that I'm not at all fluent in Python, so I think that a lot of what I wrote is a bit clunky and not good code, but I was wondering if you might be interested to take a look and possibly incorporate some of the changes onto your main branch. I think it could be really useful for some people. Well, I agree completely, and that's what's going to happen. Actually, her Python's better than mine, but I'm working on it. Finally, if it helps at all for the video you're making, here's the link to my lab's page. This is ridiculously awesome. The Triforce Institute doing nuclear simulation, fusion simulation, doing nuclear research. Basically, my university has a state-of-the-art laser, which is currently being used for nuclear research. My team is working with the laser lab to write code that can accurately simulate physics at similar conditions, and is going to be all open source and free to use so that other universities can do similar nuclear research without needing to have a massive building-sized laser at hand. See what we're a part of? Just by accident. We're all using Blender together and with this thing, and we're going to help labs around the world. That's cool. I came in my freshman year with basically zero coding knowledge and a lot of experience in CAD modeling. I decided that I was going to focus on taking the outputs from the team's simulations and make them easier to understand for people without physics or CS degrees by rendering them as points in 3D space. Through that path, I finally came across Blender and then your add-on. Which brings us up to here. So, exciting times, my friends. Python is alive and kicking. Yes, we are not finished with this code base by any means, and so stay tuned to this channel, theplyguy.xyz, and also check the GitHub repository. All the links will be down in the description. Hey, we love you guys. Peace.